Good morning all. We are going to discuss the distance from a point to a line in space. That is today's class. And so distance point S to a line L in space. Of course, the point S is also in space. So let us see what is the situation there. So consider the 3D graphics window of GeoGebra. So consider 2 points, one here and one here. So drag these 2 points. So you drag this to here, you consider this here, so you plot a line L passing through these 2 points. So you may make its color blue. So let it be a blue color, so line thickness is a little bit, so that's enough. Okay. Now you consider two more points to construct a vector parallel to these 2. So you consider consider a vector joining these 2. And you consider a point S in space. So bring that. Okay. Bring this to this point. Now drag this to somewhere. Okay. Now you consider the vector joining A and E. A and E, and you consider a segment perpendicular to this one. So consider one more point. It will be somewhere here. So our problem is to find the distance between E and E. So let us bring this to our board. So you come to the class. So this is the line L, this is the line L, and you have, this is a vector parallel to the line L, and you have a point P, so you may take this as the point P, and you have, this is S, and suppose that this is N, so you have to find distance between S and N. Suppose that you have the angle between the vectors V or a Pn and Ps is equal to theta. Now from this figure, using the right triangle PNS, we have Sn is equal to so that is our distance d equal to Sn, that is equal to Ps sine theta, and you know Pn and V are in the same direction, so this angle theta is theta between Pn and Ps is the same as the angle between Ps and V. So you consider Ps cross V. So by definition, it is modulus of Ps into modulus of V into sine theta into n cap, where n is orthogonal to Ps and V. So this implies modulus of Ps cross V, modulus of Ps cross V is modulus of Ps into modulus of V into sine theta into n cap is modulus of n cap, so that is 1. So from this you have sine theta is Ps modulus of Ps cross V divided by modulus of Ps cross modulus of V. So from this equation you are getting this, and this implies, therefore D is Ps sine theta, Ps into sine theta, modulus of Ps is actually modulus of Ps, because it is the distance between P and S, Ps cross V divided by modulus of Ps into modulus of V, modulus of Ps into modulus of V into, okay, sine theta we have substituted for sine theta. So from this you can cancel one Ps, and you are getting D equal to modulus of Ps cross V divided by modulus of V. So that is this distance D and Sn. So this distance between the line L, therefore the distance between the line L and the point P parallel to V is Ps cross V into N. Ps cross V divided by modulus of V. D is equal to modulus of Ps cross V divided by modulus of V. Now you do a problem, find the distance from a line, so a practical problem, or so consider this problem. It's example 5 in your text. So So we are going to find the distance from a point to a line L, where the point S is 1, 1, 5 and the line L is 1 plus t, 3 minus t, z equal to 2t. So here draw a line. Draw the line L. So this is your line L, and you have to find S is a point in space 1, 1, 5. This is a point in space. So you have to find this distance. So if you have this one, so this is the point. It's a point on the line. So you may take the initial point. This has 1, some 3, 0. So it is obtained from this 1, 3, 0. And you have the vector parallel to this. So you have this vector is given by from these components. You have a component here, v1 is 1, v2 is minus 1 and v3 is 2. So v is I plus minus j, so you can have minus j plus 2k. So this is your vector. So now we have to find the PS. So what is the distance? D is PS cross V divided by modulus of V. Modulus of V. PS cross V. So you have PS cross V divided by modulus of V. Now what is PS? So this is the point P and this is the point S. So PS is, vector PS is position vector of S minus position vector of P. So this is 1 minus 1 I plus 1 minus 3j plus 5 minus 0k. So this is equal to 0i plus 2j plus 5k. So this is 2j plus 5k. 2j plus 5k. So it is minus this 1 minus 3 is minus 2. So minus 2. So for that, sorry for that. So this is equal to, so you have, this is the now what we have to do is you have to find PS cross B. PS cross B is determinant of I, J, K minus 2, sorry, 0, minus 2, 5. V is I minus j plus 2k. So this is 1 minus 1, 2. 1 minus 1, 2. This is equal to I into minus 4 plus 5 plus, sorry, minus j into minus j into minus 5 plus k into two. Minus j into, so sorry, we are getting this as says this is equal to I plus 5j plus 2k. I plus 5j plus 2k. So this is your PS cross B. Now you find its modulus. Modulus of PS cross B. So this is equal to square root of 1 plus 25 plus 4. This is from this one, 1 square plus 5 square plus 2 square. So this is root 30. Root 30. And therefore what is D? D is, so you have to find modulus of V also. What is modulus of V? Modulus of V is, how this is the vector 1 minus 1, 2. So this square root of 1 plus 1 plus 4. So you are getting it as root 6. Therefore the distance D equal to, therefore the distance D equal to root 30 divided by root 6. So you are getting this as root 5. So this is, now you can verify this, is it true? All these things are true. So you consider the GeoGebra again. So this distance is root 5. So So we can verify that example using GeoGebra. So you consider, consider A is equal to root 5, that is approximated to 2.24, corrected to 2 decimal places. Now you consider these two vectors and the line. So you have plotted the line M130. M is the vector 130 and N is the vector 1 minus 1 2, and the line L is like this, and you consider the point S is equal to 115, and consider the distance between S and this line X, Sx, distance Sx. So it is approximately equal to 2.24. So you can do these things using a GeoGebra. So now we are going to describe what is the equation of a plane in space. So equation of a plane in space. So we consider the GeoGebra window to find the equation of the plane, and we are going to construct something here. So you consider the GeoGebra window. So first of all, we consider a plane. For convenience, we are going to construct Z is equal to some 4, Z equal to 4 plane, and consider 2 points A and B on the plane. So these are 4 constructions. Now you consider a point, and we are going to construct a perpendicular vector to the plane. So you have a perpendicular vector to the plane, and you have a point A here, and you can also consider another point B. So for convenience, we are just making it color red, and you consider the vector lying on the plane. So these are the things that we require. So you have 2 points on the plane A and B, and you have a vector perpendicular to the plane. So we import this to our board. So this is the plane that we have constructed. So we have constructed a plane and we have imported that to our board. Now how make it a little bit bigger. Okay. So this is we are going to find the general equation of the plane. So you consider a point P on the plane. So for example, you have this point P. Suppose that this is the point P on the plane, and you consider another point Q on the plane. Probably we are going to consider the vector PQ. So you may take the point P as a general point x, y, z on the plane, and the point Q to be x naught, y naught, z naught. X naught, y naught, z naught on the plane, and you consider this to be the vector n, which is perpendicular to the plane. And set of all points which are orthogonal to this vector and which are orthogonal to this vector and passing through x naught, y naught, z naught will satisfy the equation of the plane. So you consider, so you have the vector PQ is perpendicular to the vector n. So our assumption is this: let P, x, y, z be a point, be a general point on the plane. General point on the plane. And Q, x naught, y naught, z naught is a given point. On the plane. Given point on the plane. And you consider the vector n, which is normal to, we take, let n be perpendicular to the plane. N be perpendicular to the plane. So you let n be the vector. So you let n be the vector. Some ai, n equal to some ai plus bj plus some ck. So this vector is actually, this is equal to ai plus bj plus ck. And you have PQ is perpendicular to n, therefore n dot PQ is equal to 0. So since n is perpendicular to, vector n is perpendicular to PQ, we have n dot PQ, this is equal to 0. And what is PQ? PQ is the position vector of Q minus position vector of P. So you can write that as, since we have taken it as P as here, position vector of Q minus position vector of P is vector PQ, and that we will get x naught minus x into I plus y naught minus y into j. Also you can consider QP also, QP. So you have n dot PQ. So you consider PQ to be, you may consider QP, that will be fine. So consider QP. So just for notational convenience, or no problem, you consider n dot PQ. What is PQ? Vector PQ is, no problem, okay. So vector PQ is position vector of Q minus position vector of P. So this is position vector of P is this vector, a vector from starting from origin to this, and position vector of Q is P is vector starting from origin to this. So consider position vector of Q. So it is x naught I plus y naught j plus z naught k. Is x naught I plus y naught j plus set naught k, and position vector of q is, sorry, p is xi plus yj, so that is a general point, plus k, set k. So this is equal to x minus x naught into I, sorry, that is what we require. So that is x naught minus x into I plus y naught minus y into j plus set naught minus set into k. And you know PQ is orthogonal to n. PQ is orthogonal to n. So this implies n dot a. So you know how to take the dot product. So I am just writing x minus x naught minus x plus b into y naught minus y plus c into, this is capital C, into set naught minus set. This is equal to 0. So this is equal to, so you may take negative of this to get x minus x naught, so, and y minus y naught, set minus set naught. So, and you cancel that negative 1 here. So you are getting, this is a into x minus x naught plus b into y minus y naught plus c into set minus set naught, that is equal to 0. So this is known as the general equation of the plane. So this is the equation of the plane. And if we simplify this as ax plus by plus cz, this is minus ax naught minus by naught minus cz naught, this is equal to 0. You know that a, b, c and x naught, y naught, z naught are constants, so you can let this to be c. So you are getting this as ax plus by plus cz. So you take this as d, okay, minus d equal to 0, or you can take it as plus d equal to 0. So this implies ax plus by plus cz is equal to d, where d is ax naught plus by naught plus cz naught. So this is also the equation of the plane, simply in simplified form. So you may we may have some problems. So take the textbook. You have one more equation, one more thing, n dot pq equal to 0. So you have n dot n dot pq, this is equal to 0, and this is known as the vector equation. Of the plane. So you have three things. One, n dot pq equal to 0, and you have a into x minus x naught plus b into y minus y naught plus c into z minus z naught. This is equal to 0. And you have another one, ax plus by plus cz is equal to d, where d is ax naught plus by naught plus cz naught. So how? So these are the three equations which represents a plane, and this is known as the vector equation, and this is known as the general equation, and this is also general equations as all in which the simplified form of. Now we do a problem. Now we consider the problem. So this one. So you have to find an equation of the plane through p naught x naught p naught minus 307. So you consider this. You have a plane. This is your plane, and you have p naught on the plane. So you consider another general point p, x, y, z, and this vector n is perpendicular to this. This is the given situation. So let p, x, y, z be a point, be a general point on the plane. Be a point on the plane, and you know vector p naught p, this vector p naught p is orthogonal to n, and so here p naught is minus 307 and n is 5i plus 2j minus k, 5i plus 2j minus k. We have vector equation p naught p, vector p naught p is orthogonal to n, so this implies vector p naught p dot n, this is equal to 0. So this implies p naught p dot n equal to 0 means x minus, so x plus 3 into I plus y j plus 7k, sorry, z minus 7k. So this is the vector p naught p dot n is 5i plus 2j minus k. This is equal to 0. This is your dot product is equal to 0. So this implies x plus 3 into 5. So 5x plus 3 plus 2 into y plus minus 1 into z plus 7, z minus 7, this is equal to 0. This implies 5x plus 15 plus 2y minus z plus 7, this is equal to 0. So you are getting 5x plus 2y minus z plus 22, this is equal to 0. So this implies 5x plus 2y minus z equal to minus 22. So this is the solution. So you have that vector. You may plot this using GeoGebra. You can plot this. (5x minus 2y minus z). (5x plus 2y) 5x plus 2y minus z equal to minus 22. So you may remove these things. So this is our plane. So you can see, so this is our plane. And you find that points, check whether that point belongs to, so minus 307. Plot minus 307. So it is a point on the plane. Okay, it's a point on the plane, and you draw the vector n is equal to 5y 2j minus k. So n is equal to 5, 2 minus k minus 1. Enter. So you can see that that vector is like this, and you can see it is perpendicular to the plane. Okay. So this is the situation. This blue plane is, this is our plane, and this vector is pointing towards you. Okay. Now it is more clear. This is the situation. So this vector is perpendicular to this plane. Okay. So that's all for the time. Have a nice day.